Okay, we're going to do prime factorizations using the TI-30Xa. Okay, first we need to know about prime numbers. 2, 3, 5, 7, 11, 13, 17, 19, 23, and it keeps on going. We mathematicians don't know how far. Prime numbers are divisible by themselves, or 1. 2 is the only prime number that's even. Everything else is odd. Prime numbers can't be broken down into other prime numbers, like 6. 6 is not a prime number, it's called composite, but it can be broken down into primes, 2 times 3. 6 is a composite number, broken down to primes. And we do that for a lot of reasons. We'll show you in a little bit. But let's take 10. Let's do the prime factorization of 10. To do that, we know, let's start with a small prime number, 2. I know 2 will go into 10 2 times. So 10 divided by 2 equals, and that's going to give you 5. So 10 can be broken down into 2 times 5. Okay. Let's take 50. Can we break it down into primes? Yes. It ends with 0. So 2 goes into 50. So 50 divided by 2, 25. We look over here. 3 doesn't go into 25. It ends in 5. So let's do 5 instead. So we divide by 5. It gives you another 5. 50 is equal to 2 times 5 times 5. And there's a shortcut, 2 times 5 squared. I'm writing it as a shortcut. Could we start by taking 5, it goes into 50? Yes, we can. We don't need to start with 2. But it's always good to start with the smaller prime numbers first. Okay. In class, it's possible that you're using a tree. 2 goes into 50, 25 times. 5 goes into 5, 5 times. And then you can draw it that way. Some people like the tree. I don't. I like the inverted brackets because then I can see, hey, this is the last number here is usually a prime number. Okay. Now, let's try another one. Let's try 350. Does 2 go into 350? Yes. So it's a composite number for sure. 350 divided by 2 equals, got to press that equal signs, 175. It ends in 5, so I know that 5 goes into 175, so I divide by 5. 35. Oh, good. It ends with 5. We can use 5 again, divided by 5, and it gives you 7. 7 is a prime number, so we can stop. 350 equals 2 times 5 squared times 7. Perfect. Nice. Now, why do we use prime factorization? This is one reason. If we say 50 divided by 350, and we want to reduce its fractions, don't forget your fractions are your friends. 50 is 2 times 5 times 5 divided by 2 times 5 times 5 times 7. 350 is broken down into these type of primes. Cancel, 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 that's a 1. 1 over 7. Wow. Much easier, isn't it, to reduce when you know what factors go into it. If you use this calculator, you say 50 ABC 350, right, equals, it will reduce it for you automatically. Now, if you're liking this content, please subscribe. Please give it a thumbs up. I would appreciate that. Okay, now let's do 101. 101. Now, I'll tell you that 101, if you keep going, is a prime number, okay? So you're saying, oh my gosh, we're going to try all these numbers until we find that it's prime? No. One thing we can do is we can find a cutoff point by taking the square root. So we say 101 square root, and that gives you 10.049, which is, if you look up prime numbers, the next prime number up from 10 is 11, which means that we can try 2, 3, 5, 7, and 11. If none of these work, then it is prime, okay? 101 divided by 2, I know that's not going to go. 101 divided by 3, probably not. 101 divided by 5, it's not ending in 5 or a 0, no. 101 divided by 7, oops, try that again. 101 divided by 7 equals, no, right, wait a minute. 101 divided by 7 equals, there we go, that's better. 101, you got to pay attention. 101 divided by 11 equals, no, it doesn't go into it. So this is prime number. Remember, the definition of prime number is divisible by itself. Well, of course it's going to be divisible by itself. And 1 only. Okay? How about 51? You might think about that and be like, oh yeah, 51, prime number. But it's not. Let's do this, 51, right? Let's take the square root of 51. That gives you 7.14. Next prime number up is 11. So again, 2, 3, 5, 7, and 11. So 51 divided by 2? No. Okay, 51 divided by 3? Yes. 3 does go into 51 17 times. It ends at 17 as a prime number. So this 51 is broken down into 3 times 17. Okay. One trick with some of these numbers, let's say it's 51, this 51, right? You add the digits and gives you 6. 3 goes into 6 evenly, so 3 will go into 51. Like for example, if you had 6, 9, 3, right? Well, 6 plus 9 plus 3, if you can do it in your head, right, is 18. 3 does go into 18. So 6, 9, 3 is divisible by 3. Okay? If you add the digits, that gives you a little tip. Okay. That was a lot. It went too fast. Just rewind it. Give it some time. Watch it again and again. Please subscribe. Please give it a thumbs up if you like it. Please tell your teacher. Please tell your friends. There's a lot more in this channel than just, doing these prime factorization things. There's other things in here like things to do, factoring, quadratics for Algebra 2, and a lot of stat stuff as well. I hope you have a great semester. I'll see you later. Give me a comment if you like. I hope you have a great time. Bye-bye.